All right, good morning. We are doing the sun, page 78, short read and discussion, homework questions, video to watch. You'll find all that linked on your class room work page. Okay? All right. So we're talking about the sun. We're going to talk about the sun, then we're going to move into the inner planets. Then we'll go into the outer planets, the moon, asteroids, comets, meteors, all that good stuff that is floating around out there. And we'll be wrapping up this section. Your test will be Thursday, 10/8. Okay, we will do a little in-class project. It's kind of fun. It's kind of a fun little project. Not real hard. Should be able to do it in one class period if you work at it. All right. Now, suppose you were aboard a spaceship approaching the solar system from afar. Your first impression of the solar system might be that it consists of a single star with a few tiny objects orbiting around it. And your first impression would not be that far off. In fact, the sun accounts for 99.8% of the mass in our solar system.
Wow. Cool.
99.8%. You realize that means that all the other planets
are 0.1%.
is 0.02%
Put together?
of mass put together. Okay? So that shows you, that kind of shows you how big the sun is compared to all the other
But
planets.
that doesn't make sense because
Okay.
if the sun, you can't even put a little dot on
Okay.
it compared to other stars.
Yeah. As a result of its huge mass, the sun exerts a powerful gravitational force throughout the solar system. And although this force decreases rapidly with distance, it is strong enough to hold all the planets and distant objects in orbit. Okay? Because of its massive size, 99.8%. Can you imagine that? 78. Unlike Earth, the sun does not have a solid surface. Okay? Rather, the sun is a ball of glowing gas through and through. About 3/4 of the sun's mass is hydrogen, and about 1/4 is helium. And then there is other little elements. It does make up a few other small elements, but that's a very small percentage. We'll talk about that in one of the videos that we're going to watch. There's also a small amount of other elements. And like Earth, the sun has an interior and an atmosphere. Okay? The sun's interior consists of the core, the radiation zone, and the convection zone. Okay? So you got three zones to it. Okay? Now the core, this is where the sun produces the enormous amount of energy. Okay? It's in the core. This energy is not produced by burning fuel. Everybody thinks it's just constantly burning something up. No, that's not what it does, okay? That's not how it works. The sun's energy comes from nuclear fusion. In the process of nuclear fusion, hydrogen atoms joins together to form helium. And nuclear fusion occurs only under conditions of extremely high temperature and pressure. So the temperature inside the sun's core reaches somewhere around 15 million degrees Celsius. That's like something like 27,000 degrees Fahrenheit. I mean 27 billion degrees Fahrenheit.
Put a hot pocket in
It's pretty hot. It's pretty hot. Okay?
Burn.
And that's the core. Okay, that's in the core that it's that hot. So the total mass of the helium produced by nuclear fusion is slightly less than the total mass of hydrogen that goes into it. So what happens to all this mass? It is changed into energy, and this energy slowly moves outward from the core, and eventually it escapes out into space. Okay, that's the energy that actually eventually reaches Earth. Okay, but it starts in the core. Okay. Remember they talked about in one of the videos we watched. It's like nuclear bombs going off every second on the sun. Boom, boom. And as we study World War II, you guys probably already know the damage that an atomic bomb can create
Yeah.
on Earth. And not just
It's
the,
not even half.
not just the destruction that can happen when it hits, but the long effects from the radiation and stuff. So imagine something where it's those types of bombs going off every second, just boom, 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 creating this massive energy.
That'd be pretty loud.
Yes.
The book I read about it is a little bit outdated, but isn't it still uninhabitable? The place where the bombs were dropped?
No. It is not.
You wouldn't hear it because there's
All
no
right.
sound.
But wasn't it
The
uninhabitable?
rate, we're not talking about dropping the atomic bombs yet. We would do that in history. Okay? I was just using that as an example. I mean, I'm sure you got good information, but I could talk all day about World War II. That's one of my favorite things to study.
Yeah, it's also mine.
Okay. The radiation zone. The energy produced in the sun's core moves outward through the middle layer of the sun's interior. Okay? This is the radiation zone. Now, this is the region of very tightly packed gas where energy is transferred mainly in the form of electromagnetic radiation. Because the radiation zone is so dense, that means it is so thick, okay, it can take energy more than 100,000 years to work through it. So that some of that energy that is reaching Earth is over 100,000 years old before it gets to us.
Oh.
Is that not cool? That's pretty stinking, that's awesome.
awesome.
That is awesome. Okay?
No, it's the sun. It's just
Yeah.
God's microwave.
Now, the convection zone, speaking of microwaves, right here is one. The convection zone is the outermost layer in the sun's interior. Hot gases rises from the bottom of the convection zone and gradually cools as they approach the top. And then the cooler gases sinks, forming loops of gas that moves energy towards the sun's surface. Think about when we talk about solar winds and wind currents and all that, okay? They loop around. They get hot at the equator, they go up near the poles, they cool down, they come back, okay? Water does the same thing. Here it is, the sun is doing the exact same thing. You know, we talked about how God created things. He didn't reinvent the wheel every time he did something. He had a plan, and you can see the similarities in so many of his creations, the way they work. But a convection, we now have convection ovens that are energy efficient, and that's the way they work. It heats up down here, and the airflow then moves it up, and as it cools down, it comes back down and heats back up, and then it moves back up again. And that's called a convection oven. And those, you know, that's one of the, well, it's not new, it's been around for a number of years now, but when that first came out, that was like, wow, that's really cool. Yeah.
The craziest was
Saves
when they
energy.
first saw the picture
It
of
saves energy because
It does save energy.
because it goes back down instead of just being trapped out there and then going
Exactly.
out when you open it. It goes back down and up so that it wastes less energy
Yeah.
on using more hot air because the hot air recycles.
Yep, and that's when Caleb was talking
It
about
looks like a
how that actually saves energy. Yeah, if you have 2 stories in your house, okay, if you're noticing in the wintertime when you got the heat on, if you go upstairs, sometimes it's a few degrees warmer upstairs. Because heat, of course, rises. The heat rises, okay? All right, now the sun's atmosphere. The sun's atmosphere includes the photosphere, the coronosphere, and the corona, or the chromosphere, excuse me, and the corona. Every layer has unique properties. Okay? The photosphere, if you're into photography, you're going to recognize some of these terms in a second. Okay? The inner layer of the sun's atmosphere is called the photosphere. The Greek word photo means light. Okay? So photosphere means the sphere that gives off the visible light. Okay? The sun does not have a solid surface, but the gases of the photosphere are thick enough to be visible. And when you look at the image of the sun, you are looking at the photosphere. Okay? And it's considered to be the sun's surface layer, even though it's not solid. Okay? The chromosphere During the total solar eclipse, the moon blocks light from the photosphere, so you no longer produce that glare that keeps you from seeing the sun's faint outer layer. And at the start and end of a total eclipse, you've got that reddish glow that is visible just right around the photosphere, okay? And this glow comes from the middle layer of the sun's atmosphere, the chromosphere, okay? That is the Greek word. Chromo means color, okay? Because you see the coloring of it, okay? And then you got the corona. During a total solar eclipse, even fainter layers of sun become visible, as you see up here in figure 7. That's kind of like that halo. Remember when you were a little kid and you would draw pictures of the sun and you would get rays coming off of it?
Yeah.
Sometimes it would just be lines coming out around it, off of it. Sometimes you would do the whole little, stair-step looking thing going all the way around it. You were actually drawing the corona. That's what you were drawing, because that's what you see. That's the halo, basically, that surrounds the sun, okay? So the outer layer, which looks like a white halo around the sun, is called a corona, which means crown in Latin, okay? The corona extends into space for millions of kilometers, and it gradually thins into streams of electrical charged particles that is called the solar winds, okay? So, for hundreds of years, scientists have used telescopes to study the sun. They have spotted a variety of features in the sun's surface. Okay? Features on or just above the sun's surface include sunspots, prominences, and solar flares. Okay? Now the sunspot is actually it's that darker spots that you see on the sun. And what causes them, there are actually areas of gas on the sun's surface that are cooling. And the cooler gases looks darker, okay? And they will move. The cooler gases don't give off as much light as the hotter gases, which is why sunspots looks darker than the rest of the photosphere. Sunspots seems to move across the sun's surface, showing that the sun rotates on its axis the same way that Earth does. Okay? So a number of sunspots on the sun will vary over a period of about every 11 years. You will see these sunspots in the various places. They always seem to be in the same places. But what's happening is the sun is actually moving on its axis also. So it takes a while for us to re-see them. Okay? Pretty cool. Okay? And then you got the picture here on page 81 that shows you the core. We're going to look at a real quick video.
The sunspots?
The second one we watch will show you. The guy will draw out these for you, kind of label them. Yes?
Somebody drew something bad in the book.
Well, we did just order these, so I will take a look at it in a second. Thank you.
He didn't write it.
No, I believe it. I'm not saying he did. I appreciate him bringing it to my attention. Okay, I'll take a look at it in a second, Bruce. Okay, prominences. Sunspot usually occurs in groups, huge reddish loops. Okay, you'll see some of these in a second on the video. They are called prominences. They often link different parts of sunspot regions. When a group of sunspots is near the edge of the sun, as seen from Earth, these loops can be seen extending over the edge of the sun, okay? And it does. There's like big loops coming up off of it. You can see one on page 81 again up there at the top in the little part. It shows you, and it is. It's almost like a loop. It kind of comes off and goes back down to the surface again. Yes, Leo?
The sunspot that they show on page 81 right here, and the black part kind of looks like a heart a little bit if you think about it.
It does. Yeah, it does.
Not like a flare around
Yeah,
it. It's
yeah,
just
but the
black
inside,
part.
yeah, I see it. I do. It does. It kind of looks like a heart, doesn't it?
It's pretty
Okay?
cool.
It is. Solar flares. Sometimes the loop in the sunspot region suddenly connects, releases large amount of magnetic energy, and the energy heats gas on the sun to millions of degrees Celsius, causing the gas to erupt into space, and these eruptions are called solar flares. Now, this doesn't tell you, but the core is about 15 million degrees. The outer part of it is somewhere around 9 to 10 million degrees. Okay? And this is going to shock you, but when we study Earth, the Earth's core is actually hotter than the exterior of the sun. That's scary, isn't it? Think you're sitting on something that hot? Yeah, buddy. Okay? Solar winds. Solar flares can greatly increase the solar winds from the corona, resulting in an increase in the number of particles reaching Earth's upper atmosphere. Yes, sir. Normally, Earth's atmosphere and magnetic field blocks these particles. However, near the North and South Pole, these particles can enter Earth's atmosphere. And when they can create a powerful electrical current that causes gas molecules in the atmosphere to glow. And the result of these rippling sheets of light in the sky is called what? What do you think?
But I wanted to say one more thing. What do you call it in the sky in the North Pole? Something like glows in the sky?
Yeah, the northern lights.
Yeah, the northern lights, is that?
That's the aurora. That's it. That's what we're talking about.
That's the
I always wonder what the northern lights were called sky.
That's exactly what we're talking about. Yes, sir.
I had a nightlight that has all the planets, and then I have another one with the northern lights.
Oh, that's cool. We're talking about it has a night light that has all the planets and the northern lights. So that's pretty cool. All right. Solar wind particles can also affect Earth's magnetic field. Okay, now this is pretty cool right here. Causing magnetic storms. Magnetic storms sometimes can disrupt radio, telephone, and television signals. Magnetic storms can also cause electrical power problems. And it used to be, especially in the summertime, if your cable would go out or something like that, you would get a notice sometimes, and it would talk about how it was because of solar flares that was getting spotty. It was an electrical storm that was causing this. California loses, they have these Roman power outages sometimes where they will have a section will be without power for 2 or 3 hours a day, and then it comes back on, and that's what they blame it on. A lot of times they'll blame it on the solar flares and say it's the magnetic storms causing it and stuff like that. And it's possible. It's very possible.
So when my mom was from the Dominican Republic, I don't know how long ago, but she was probably like 20, and then their power went out it was either the whole day or the whole night. I think it was the whole day, and then it was
Yeah. He's telling about his mom was on a trip and the power went off for like a day or so. So that was pretty, wow. Okay. All right. Again, check your classwork page and you will get all your instructions. Bye-bye.